and welcome to our What's New session for SAP HANA 2.0 SPS 08. This time we would like to talk about mission critical data center operation. And with me here is my colleague Ruediger Karl. He will take care of the second part. Very interesting stuff about NSE, and myself, Ralf Czekalla, from SAP HANA Product Management. With that said, we have created quite some stuff and brought with us quite some stuff for this session. So we'll have a short intro, of course. Backup recovery will be a big topic. Persistence and infrastructure, high availability, native storage extension. As said, this will then be the part from Ruediger, and workload management, partitioning. So very interesting potpourri of items and news you would like to watch with us. That said, we are finally coming to the next SPS. As you know, we have still SPS 5 in the long-term support for quite some time until end of next year. SPS 7 is out, very strong change on customer side to this release. And now we bring out SPS 8. We changed a little bit the support time. You will see here in the slide, we are now with 4 years instead of 5 years. We went away from this long, short, long mechanism. Instead, we always have 2 years of overlap, giving our customers enough time for migration projects. And 4 years of support, I think, is also a good compromise for our customers. That said, we have a lot of sessions, and you will see maybe some of them here. You find them with our SAP HANA developer channel on YouTube. The first session, the overview session, was done together with our partner On24. If you would like to watch it, please register with the given link. Simply to not only watch the recording, but also get the slides of this presentation. The other sessions you will see here will run over the next days, so very beneficial for you at the end. So what is the overall scope of SPS 8? To give you a broad picture, the overall scope, like with the other ones before, SPS 5 and SPS 7, is quality and stability. Of course, we don't want to disturb the operation. We want to keep the quality as high as possible so that our system continues to stay as stable as you are known it for SAP HANA. Accordingly, you will find on these slides round-offs, feature round-offs to fill this or that gap. But the core is not much touched here with the features to keep exactly this quality you are expecting. So planned release was on November 20th, you know, the day before. We have a release note as usual. So have a look over there, giving you some last minute information. And of course, we also have a landing page for these What's News in our SAP Help portal. So this is a good starting point for digging into the maybe later help you would like to have the details on. I also try to put in as many links as possible so that you do not have to search much within the our help portal, but to get directly to the point of the item I am presenting. So first step, backup and recovery. Always interesting, always important. Here we have 2 changes, left and right on the slide. On the left side, you see we are now supporting a new encryption algorithm. It's AES 256 CTR. And while we keep, of course, the other ciphers we had before, cipher blockchaining, CBC was the former one. It's still there, it's still used, it's still the default. And the new one is a CTR because of certain demands from customers, from partners. We also introduced this one. It has some capabilities in parallelization. That's encryption process, as you can see here on the slide, can be parallelized instead of the CBC. And this gives us, of course, some benefit. And we try to prevent some threat contention here within or outside of HANA. Inside of HANA, we try already to use multi-threaded processes, but sometimes the outside world also need to have this capability. As said, the default will stay the CBC. Only in certain legislation areas we need to offer this CTR, and there it often is also the default encryption cipher we are using. How to enable, there's also a link. All this stays and falls with the master key or the key you provide with installation, or if you change this key later on, the header of the key contains the cipher algorithm, and from there HANA is taking the information and then changing all the depending keys in the system to get everywhere the CTR in place. On the right side, we now have some convenience for our customers, you could name it. We are now including our local secure store, or sometimes abbreviated to LSS, backups into our standard native SAP HANA backups, which makes the whole process quite easy for our customers. They don't have to keep out and watch out for these local secure store information, that the backups also get included into the normal backup. Now this is handled automatically. And this helps, of course, to make the life of our administrators easier. When this is, of course, a logical consequence, because the LSS secure store is now also the default secure store for new created SAP instances. So the old ones will stay and take still the secure store file system, as you see it here. And new created instances will get automatically the local secure store. And then, of course, this feature is kicking in and the backups are kept and taken for the general native backups of SAP HANA. Also, again, some links to the local secure store. What does it mean? How to backup and recover. So makes it life easier for you. Next one, what's new for persistence and infrastructure? Here we have some detail optimizations. The first one is a supplementary detail from SPS 07. Somehow it went under the radar. And now I would like to take this audience to make it aware to you that in SPS 7 late, we introduced an active encryption process, persistency encryption process, to make the life again of our administrators easier. In the past, we had more or less a passive process. Every time a page was read from the unencrypted disks or unencrypted part of the data volume and rewritten down to the disk with merge or whatever is writing to HANA's data volumes. Only in this process, the encryption was happening. So now we have an active process here triggering IO workers on these data volumes to read stuff as a preparation, as an active process, and writing it down later in an encrypted way to the data volumes. With that, we don't need all these other hints and tricks before, where we used backup and recovery, for example, in place, or we use system replication, created a replica secondary, and let this one fully load. And this is fully load process. All the pages were directly stored in an encrypted way in the data volumes. All this is now gone with this active process, which is triggered automatically with the change of the encryption. So again, here a link to the data and log volume encryption help page. So this might help to get even deeper into that topic. Next to that, also a minor detail, our diagnosis tool, known for quite some time, HDB-PERS-DIAC, is now supporting also data volume partitioning. On the right side, I tried a little bit to illustrate what it means. We can slice up our data volume. HANA started typically to have one data volume. In SPS 4, we introduced the possibility to slice up this data volume if the underlying file system didn't allow so big files, then you could have multiple partitions, and they are written round robin as strong as they are filled. They are tried to kept in sync a little bit, but there's no active striping, from storage systems on the market. This was also downported to SPS 7 to revision 79.01. And again, a link to the persistence consistency check where this HDB-PERS-DIAC can also be used in the process. Next one is about NFS handling. Here we had, in the past, sometimes quite nasty situations. NFS is sometimes a little bit picky, I would name it, meaning if a mount point is not responding, clients can wait for these acknowledgements or communication pieces coming from the NFS server. And until they don't get this kind of feedback, the NFS client technology is simply blocking everything on that mount point. And accordingly, if HANA is using NFS, it has also quite some troubles here if the NFS server is not responding in time. So instead of a downside up process we had in the past, simply looking on every mount point, NFS mount point or mount points in general, now we are using an upside down process. So HANA itself is checking the mount points and only using and confirming that they are existing, these mount points which HANA itself is really using, not the other ones which may lay around like it did before in earlier versions. And this is now helping at least to prevent that some forgotten mount points might have a side effect on SAP HANA operation. That said, we not only change this behavior, we want to actively inform our customers about that their NFS calls hanging in between. And with that, or for that, we introduced a customer visible alert. This is a central alert 21. There's also a note describing how to handle it best way. So already for other situations. So this one would be very similar. So I hope with that we make it more visible that HANA is not waiting and hanging because it crashed or did something, but it simply is waiting for this DF, what's happening in the background, or the system call to that, to simply get a response from the NFS server, which is simply not responding. So this might help here and there in certain situations. Next, some details about infrastructure. As you can see here with the first point on the left side, we want to switch from Python 3.8 to 3.12. You might know that HANA 2 always has a Python interpreter with its delivery, and it's used for internal orchestration. Sometimes also our customers are using it for creating own scripts. In the context of the SID ADM, you can also check which version is installed on HANA. Simply SU to the user, SID ADM user of your instance, and then you can do this Python -- version, and then you see which version is actually available within the context of HANA. So here we have to switch because 3.8 is going to end of support. So 3.12 will be the next one. And as you see in the gray box on the right side, it will probably get support until October 2028. So we have covered quite some ground here with this change, and the roadmap link to the note describing the expected roadmap is also listed here for your information. Second item on this slide is, simply speaking, a possibility which was demanded from several customers over quite some time. And finally, we got this feature, an IP-based connection restriction for user groups, which is definitely not replacing a normal firewall, but it helps also in smaller areas, let's say within your company, to restrict certain admin accesses to certain IP addresses. Maybe you have some kind of a gateway PC from where you can then do this administration work like we have here at SAP, for example, typically. And then you can restrict accesses to the vital systems via this IP address of this PC. But it's definitely not securing against IP spoofing. So it makes always sense to have a full-grown and fully functional firewall instead, which does package inspection. And you know the game probably better than me. So again, the link to the connect restrictions and help page where you can find the information how to set it up and how to get to this segregation of duty at the end. Last one, support for TLS version 1.3. Protocol. It's state of the art, and I don't need to explain it, I think. Anyway, I put some details here. It's a most actual protocol here, gives speed enhancements, security enhancements, and so on. We act at the current point in time, we have not the limitation, but you have to have the information that in and outgoing SQL connections can be used with 1.3, and for the outgoing support, also HTTPS with TLS 1.3 is supported. Yeah, so very helpful. Staying with the state of the art is always beneficial at the end. Next topic, high availability. Here we also have some interesting pieces. The first one is takeover with handshake. You may have heard it with SPS 6. We introduced this takeover with handshake, or even earlier. And now SPS 4, you see it here in the first line. And with SPS 8, we are now extending it. The challenge is what I try to explain a little bit graphically on the right side. This takeover with handshake works with suspending the log writer on the primary side. So with that suspension of the log writer, no changing operations can happen anymore on the database, but reads. So our recommendation in the past was always, please, dear customer, isolate the primary accordingly. So maybe raise a firewalls around it, deactivate client network ports so that the clients get actively informed that this primary is not reachable anymore. We had some feedback from customers, they forgot this detail, and so now we want to also introduce an SAP own feature for this isolation option. And this is actually the option we have now in place. This is a stop primary. So if we trigger this takeover with handshake, what we still do is a suspension of the log. We can even wait for a certain period of time for transactions to finish. So new transactions are not allowed, but old transaction can, for a certain threshold time, finish their work. And then the takeover is triggered. And before the takeover, in the last step is triggered, a shutdown is happening on the primary side. This is has pro and cons. Pro is that we now have an own option here at hand for SAP HANA. But the other older version was also not bad. It gave you the possibility to isolate the primary on your own terms, I would name it. And with that, you had still the possibility to analyze what's going on the primary afterwards, because it was isolated, it was still running, but you had the chance to analyze the situation, to figure out, do a root cause analysis and something like that. This might not possible with a shutdown, of course. Of course, you could restart the box later on and start the analysis afterwards, but it might then not represent the same situation as before the shutdown. So this is two sides of a coin, as usual, and you have to decide which of these choices is the best you can use. Next slide. System Replication Status PY is also a well-known feature for quite some time. It's a statement which a Python script which can give you some details about the state of the replication. And this one was only executable on primary so far, and now we introduced a possibility to also execute it on the secondary. You see the option here, get secondary statistics. You see a screenshot. Yeah, I had to cut it a little bit here on the slide, but it gives you the details I would like to look for. So here you see side A, and we are executing it on side B. And you can get statistics from the replication which is happening. In the past, often customers try to use this information also to do a takeover go or no-go decision. But here I have to say this is based on the HANA's own replication process. So as long as this replication is in place, everything is fine. The data is up to date. It's kind of somehow event-driven. So as soon as information happens on the primary side, for example, it's replicated like the normal replication flow of redo log, and presented and kept on the secondary side. But as soon as the primary is gone, there will not be any further information on the primary side on the secondary. So for this kind of situation, we still need a proper cluster manager, which has this overarching monitoring of all the replication partners involved in this setup. And often it's for us like a quorum or witness instance. Sometimes it's also named witness instance, to take care that all informations across the whole landscape is seen, and not only the one on the one host where the secondary is, for example, running. There's also a nice guideline for you. If you are in these kind of situations, it makes sense to look into this note 2063657 takeover decision guideline to get better to the final statement. Yes, a takeover is beneficial here and the way to go forward. In the last feature, and with that, shortly after, I will hand over to my colleague, Ruediger Karl. The last one is here, a new parameter we introduced for active-reactive read-enabled secondaries. You know, we are offering active-reactive read-enabled already for a real long time. Actually, we introduced it right away with the beginning of HANA 2.0. So this one is, yeah, very good settled within our customership. We introduced a parameter in the beginning to take care that memory is there for this replication process on the right side in the picture, that this one is really the backbone kind of flow we need. So for this, we introduced a memory limit, that we still get enough memory for this process. And now we introduced also a similar limit on the thread side, on the CPU side, or the virtual core side, so that we still get enough CPU on this replication process. You know, this is a backbone, and we need the process to happen. Otherwise, we would have a delay between them, and even maybe if it's a sync replication, we might even see a feedback loop to the primary side and get it stuck. So this is simply the reason to introduce this. There are some options here, as you can see. Default is the old setting, or 0 to deactivate this. If the value is bigger than 0, it's the number of workers which are permitted. If you set it to -1, it's per se like the other parameter, the memory limit, 50% of the max concurrency, or 50% of the available cores are then reserved for this replication process, and the other 50% for the active read-enabled offloading, which can happen here on this secondary. Also here, link to the configuration parameters might be useful, and also dedicated to the memory management, there's also this new parameter listed. So have a look, and I hope you have enough good pleasure with the next step, with the next part from my colleague, Ruediger Karl.
Yeah, thank you, Ralf, for this nice presentation. And so I will now share from my end the presentation. So I hope you can see them okay. All right, Ralf is nodding, so I will continue. And in my part, I will cover features and innovations for SPS 8 in 3 major core areas of HANA. That's native storage extension, workload management, and partitioning. And I will start with the native storage extension. And you see there are 3 features we will introduce. That's the unified persistence, then several automation capabilities in NSE. And then I will go over to the dynamic partition aging, which is itself a partitioning topic, but very much related in the context of the native storage extension. So what is about the unified persistence? Before SPS 8, we had 2 different persistency formats for data in memory and data in NSE. So whenever you have defined tables, partitions, or columns as being managed as in-memory data or in-memory structures, you have to change the load unit, or vice versa. If you would like to manage tables, partitions, and columns in NSE, you have to change the load unit. And each change of the load unit came with a persistency format conversion. That took some time, depending on the data that you had in your system. And for very large tables, this time was affecting also the business uptime for companies. So we decided 1.5 years ago to start with a new project, which was called Unified Persistence. And Unified Persistence harmonized the persistency formats of tables in memory and tables in a native storage extension. So no data conversion is required anymore when you switch from in-memory to NSE, and vice versa from NSE to in-memory. And this reduces significantly the business downtime that you had faced before, and that was quite challenging, as said. So with the unified persistence, you can then easily switch between both table management, so to speak, in NSE or in memory. It simplifies the administration. So it's a huge step forward also in the direction of NSE automations, because now it's a matter of seconds to change the load unit and change also then how tables are loaded into memory or into NSE. We enabled unified persistence by default for SPS 8. So that means whenever you upgrade to SPS 8 with your existing data, they will be converted to the unified persistence format one time. And this happens when you write to a table the first time. Then we will convert it to the unified persistence format, and then it's done. Everything is prepared that you can switch the load units for your tables, partitions, and columns. And writing to a table can also happen by a delta merge operation, which is an internal HANA operation, or an compression optimization, something like that. So that happens more or less in the background. You don't need to trigger this explicitly from your end. That happens after your upgrade and after you write the first time to your table or to your tables in the HANA system. And as said, when unified persistence, the unified persistence format is in place for your data, then you have all the benefits of unified persistence to have to switch between in-memory or column loadable load unit and NSE, that's the page loadable load unit. We also added a column into a monitoring view. It's called MCS columns persistence. Maybe you use it for your own monitoring. We use it in also in our HANA cockpit for sure to monitor our data in NSE. We added a new column. It's called load unit, because the persistence type, which is a column in this monitoring view, will show the same value that's unified. And so whenever all data are in a unified persistence format with SPS 8, the persistence type will show only the value unified, and you cannot distinguish between NSE data and column or in-memory data. You need the load unit to be filtered additionally as an additional condition to get out what are data in NSE and what data are in memory and as column loadable. This is already in our HANA cockpit, so everything is there. But in case you use your own monitoring with these monitoring view, you have to have a look at that you have the right filter conditions to get out some data about your about NSE. There's also an SAP note that explained it in more detail, and it's also here in this slide. All right, what else? As said, unified persistence is the door opener for future automations in NSE. And here I just sketched more or less a kind of NSE lifecycle automation you can establish in your system with SPS 8, because it contains now also automations in NSE Advisor, and also in some other mechanisms of NSE. You can do it manually for sure, but it gives you also an impression how you can more automate your NSE management. And you see here, and I will go to each step individually in the next couple of slides. You start the NSE Advisor. The NSE Advisor will calculate recommendations for your data being managed in memory as column loadable or being managed in NSE as page loadable. And you can define if these recommendations should be applied automatically. And here the advisor is benefiting or leveraging the unified persistence innovation. So because this auto apply happens very, very fast, and so the advisor doesn't need to wait for this change of the load unit. The advisor will historize all recommendations in a table so that you can review the recommendations that have been made by the advisor, at which time, which configuration parameters have been used, have they been applied automatically or not, all these things. That's another innovation. I come to that later in a slide. In NSE, we also auto-calculate the unload threshold value, which is an parameter we introduced with SPS 7, and I will come to that in more detail also in the next slides. And we will, based on the unload threshold, we will release allocated memory automatically if it's not used anymore in the buffer cache. So we give memory back to HANA to use this memory for calculations, for any kind of query processing, etc. So it's not claimed anymore by the buffer cache. Okay, so again, this is a kind of proposal how you can automate your NSE lifecycle. And now let's come to the individual steps. You see, step one, you start the NSE advisor, and you actually have two options. One option is you start it by changing the INI parameters in SPS 8 to enable and disable the advisor, but you can also start with the built-in procedure. The built-in procedure has been introduced since SPS 6, and you can even schedule the built-in procedure. And what you do is, with this built-in procedure, you can pass a duration to the advisor, how long the advisor should run. You can also pass any other configurations parameter to the advisor that should be considered for the recommendations. Once the advisor is finished, based on the defined duration, the auto advisor, the NSE advisor, will auto-apply these recommendations if you have defined it in the advisor recommendation rules. These rules has been introduced with SPS 7. So you can define which schemas, tables, columns, or partitions should be considered by the NSE advisor for recommendations. And you do this by inserting these rules in this system table that's delivered together with SPS 8 and also with SPS 7 already. And there you insert your rules. In this example, you say for a schema as one, that's the name of the schema, all tables, all partitions, all columns should the recommendations be automatically applied, right? You can also have here a null. That means it's not applied automatically. So you have full control about the data that should be automated for the NSE advisor recommendations to auto-apply them. So full control, you can disable, enable them. So very convenient. There are some limitations for hash range and the range hash partitions. So keep that also here in mind. But again, this step 2 gives you here the capability to auto-apply your advisor recommendations for specific schemas, partitions, tables, columns. Step 3, the NSE advisor will auto-store these recommendations in a history table. Here you see the name of the history table. And you can define the retention time. By default, it's 1,095 days, 3 years, I guess, that all the recommendations are kept in this history table for later analysis or later review, etc. In step 4, that's also new in SPS 8. We auto-calculate the unload threshold value. The unload threshold parameter has been introduced with SPS 7, as said, and the unload threshold is a value that is considered by the buffer cache to release allocated memory that has been allocated before due to any operations that happens maybe once a month, once a year, or once a week, and then you have allocated memory in the buffer cache, and it couldn't be released before SPS 8 unless you have restarted the database. And this was quite challenging because the memory is claimed by the buffer cache. And so there was the request, how can we release this memory if it's not used anymore, right? And so we have this unload threshold that is a threshold value where the buffer cache will release memory, and once it's reached, then it's done. And with SPS 7, you had to define this value or this value as an INI parameter manually. And now with SPS 8, we calculate it automatically. And this is very, very precise based on the actual persistency disk size of your page loadable data that are in NSE. So we will auto-calculate the value by just evaluating the persistency disk size and then apply the ratio 1 to 8, maybe very common and very known to you, to calculate this unload threshold, and then HANA will then initiate the release of unused memory in the buffer cache. Okay, this happens then in step 5. And then again, you can start the advisor, and then everything happens from the beginning. All right, just more informations about the buffer cache automation. As said before, the buffer cache in before SPS 7 has been increased whenever data are loaded into the buffer cache. More and more memory is allocated. You see here the allocated size usually starts with 0 when you start the database the first time or when you have restarted the database. And then data are loaded from disk into the buffer cache, and the allocated size is increasing all the time. And then the buffer cache will never release the memory. So it could increase until the max size is reached. And what happens is maybe you have a used size of a very small portion, and then we have unused allocated size, which is then, it's not effective. It's not very effective to use the memory, and that was before SPS 7. With SPS 7, we introduced the unload threshold. It was deactivated by default because we didn't want to harm your actual settings. So it's by default inactivated in SPS 7, and it's the percentage of the max buffer cache size. But at the end, what happens is HANA will try to decrease the allocated size by releasing the memory until the unload threshold is reached. So we can use the memory much more efficient in HANA. And you see here the allocated size is much smaller than on the left side before SPS 7. But again, the disadvantage was you had to define the unload threshold parameter manually. And now with SPS 8, oh, okay. That's again a visualization of the elasticity of the buffer cache in SPS 7. Just as another recap, you see you start with 0. You load data in the buffer cache allocates memory, and then the used size is also increasing. Then the used size or the usage is decreasing again because it was a one-time operation before reporting for any kind of executions on your NSE data. HANA, the buffer cache will release memory automatically until the unload threshold is reached. So the allocated buffer cache size is decreasing and very close to the used size, which is the ideal case, to have them both very close to each other. Then the used size maybe increases again because another weekly or monthly reporting had been started. The allocated size increases again, but after this happens, used size is decreasing, the allocated size is following until the unload threshold is reached once again. So this is just how the buffer cache is breathing over time to allocate memory and deallocate. And this makes our memory usage quite efficient. Okay, and with the SPS 8, we automated that in the way that the buffer cache calculates in regular intervals the unload threshold. And then the unload threshold is reflecting the persistency size, and then the buffer cache releases allocated memory, but unused memory. So that's automated in the way that you can define an interval where the unload threshold is recalculated. So you see on the right side the buffer cache or the feature details for this automation. You see here, just maybe here as one thing is if the automation mode is enabled, and you do this just by setting the automatic unload threshold interval higher than 0. Default is 0. That means the automation is disabled at all, but then you set the default value higher than 0, let's say to 5, which means 5 seconds. So every 5 seconds, the buffer cache would recalculate the unload threshold value, which actually is not the common usage. We would say once a day, you would auto-calculate the unload threshold. So you define the interval in seconds for a day. And then once per day, the unload threshold is recalculated. And then the buffer cache will release the allocated memory to the unload threshold. And what you else can define is what is the ratio of your unload threshold value, where which is actually the max size then of the allocated size, more or less. What is the ratio between this size and the NSE data? And here we applied by default a very common ratio that's 1:8. So that means the buffer cache has, let's say, 1 gigabyte, and the NSE disk size has 8 gigabyte. So this is the ratio that we apply by default. You can define other ratios, so you have full control how the unload threshold is calculated by the buffer cache. All right, so, and this, I mean, when you add new data, it happens, or that the unload threshold is adjusted automatically, or if you, let's say, revert some data from NSE to in memory, then here also the buffer cache will auto-calculate the unload threshold based on the interval you have defined. All right, now we go over to the dynamic partition aging, and it could be also, by the way, a part of this NSE lifecycle automation to some extent. Because what you do here is you define a range partitioning for your table that includes a dynamic aging of partitions in memory to NSE. And how this happens, here you see a picture once again. You define a table as a range partition with a range partitioning schema. And what we have is that you define a dynamic interval. That means whenever you see here as an example, you have a range partition defined between 0 and 2022. So the year is the partition column. Latest record is 2020. So whenever you add a new year into the into the table here, 2022, and you see the range partitioning is below 2022. This record is added or inserted into the others partition. What happens is if you have a dynamic interval, HANA will add a new partition from 2022 and smaller 2023. It depends on your partition scheme, but this is just an example. So that means that happens automatically by an HANA background job. Yeah, there you can also define the interval when that should happen. And this is an existing feature. That's not new with SPS 8. That was already back in former SPS releases of HANA 2. What we added with SPS 8 is that we added a new clause. That's the distance clause, and that's an extension of the dynamic interval. So that means after a partition is added, and another HANA background job will calculate what is the distance between the newest record, date 2022, and the record that is in the range partition that you have between 0 and 2022. And if distance exceeds the distance you have defined for the dynamic range partitioning, and in this example it's 1 year, then the oldest partition is moved to NSE automatically. So that means this one table partitioning definition, you define how partitions are added for range partitions and how partitions are aged to NSE automatically. And just imagine that with the buffer cache automation, the buffer cache will recalculate the persistent size. It has been increased, right, because of the new aging here. And then it's considered also for the let's say the release of memory to HANA. Here in that way, it would affect that the unload threshold will increase as well because you have more data in your NSE persistent size. Okay, now we come here to some examples. You see here some additional feature details about the dynamic partition aging, which partition columns, which data types are supported as partitioning key. You see that we have the distance property added to the dynamic range partitioning, but I think more interesting is the example here that I have in the lower half of this slide. Create a table T with a date column, and the date column is your partition key, and your range is a year, is the year, and it reflects the picture in the slide before. And you have a partition from 0 to 2022, and the others partition, which has a dynamic interval of 1 year, and a distance of 1 year, page loadable. And then everything is done. So you don't need to trigger something. It's automatically, but you have still full control to modify the distance. You see here with an alter table, alter partition statement, you can define the distance from 1 year to 2 years. You can also trigger the dynamic aging manually by refreshing with alter table refresh, or you can also switch off the dynamic aging. So have full control about your range partition tables. All right. I think that's all about dynamic partitioning, dynamic partition aging in the context of NSE. So what's new in the workload management? You see there are 3 features that we have introduced in SPS 8. The total thread limit in active read enabled environments that has been or had been covered by Ralf already. So I will come to the other ones. The optimized CPU utilization of HANA systems. We introduced a new configuration parameter. It's an INI parameter. You define in the global.ini or index server.ini. It's the default statement concurrency max limit parameter. It helps to avoid any underutilization of your system. The reason is you have maybe defined some statement thread limits in your workload classes, or you have defined thread limits or any statement concurrency limits on a global level. And so that means these limits, they are kicked in immediately when you have defined them into the system. And so even the system is underutilized, the statements will, or the thread limits are applied by HANA to your query processing. With the new configuration parameter, you say, what is the threshold where the limits are not applied? So that means if the system has a very low utilization, CPU utilization, all the limits are ignored for thread limits. So the queries, they can run with all the resources that are available, until the default statement concurrency max limit is reached. When this limit is reached, the statement thread limits are kicking in for all new incoming statements into the systems. So that provides an optimized HANA system utilization in the presence of defined CPU resource limits. These are the thread limits for workloads. When you set this parameter, by default, by the way, it's 0 because so that means it's deactivated. Again, we do not want to harm existing configurations in your SPS 7 systems that you want to upgrade to SPS 8. So we don't want to harm them. So it's by default deactivated. When you set it to a non-zero value, that's a bit the expert mode, because what HANA is doing is it increases the running jobs until the number of jobs that you have defined as a non-zero value for this statement concurrency max limit. So you should be very, very familiar with the number of jobs that we are running in HANA, which is, I would say, a very, very expert level. Much more convenient is to have a percentage where you define a percentage of CPU utilization. You say 50% is your default statement concurrency max limit. That means the HANA system will increase the number of jobs until the CPU utilization is 50% of the system, and then the limits are kicking in that you have defined in workload classes or maybe on global level. So that means the HANA system internally will monitor also the CPU utilization of the HANA system, and until the threshold is reached for this that's the parameter, the job worker will increase the jobs that can be used for processing queries, and no limits are applied. So that's the reason behind, and quite useful to really avoid underutilized systems. Further performance optimizations are faster job cancellation. So whenever you canceled a session, the jobs are also have been canceled and now removed faster from the HANA system. So that leads to performance improvements because the allocated resources are released much faster. Another performance optimization is the support for transparent huge pages. You need as a prerequisite SUSE Linux 15 SP5 or Red Hat 9.2. So these are the prerequisites that HANA supports the transparent huge pages. So for really big HANA systems, we can now allocate large blocks of memory very fast, very efficient, and we can also deallocate them very fast. So we talk about pages from 2 megabyte to 512. So that's now enabled with SPS 8. And last but not least, and we are on top of the hour, unfortunately, for partitioning, we have introduced a 3-level partitioning for heterogeneous partitioning schemas, so range, range, hash, and range, range, range. And usually, what we have seen in customer systems with S/4HANA, they are using number ranges, and number ranges in very large systems, they can really increase to a huge amount of data, where you have the need to partition your tables accordingly, and also for scale out systems with number ranges, with huge number ranges and a huge number of records for your number ranges, you will benefit from this new feature. It's for instance, you have for your number ranges, you have a range partitioning, and under a specific number range, you have an extremely high volume of records, and we have this 2 billion record limit still, and maybe forever in HANA. You are then enforced to split your table on the lowest range partitioning level to hash that you can split again, this range partition with hash partitions to avoid the 2 billion record limit. So this is just one use case, and very prominent as that is the usage of number ranges for really huge HANA systems. Partitioning on generated columns was also a request by customers because the identity column is very, very popular to be used where you have a column that generates automatically IDs in your table, and now you can use this identity column as a partitioning key due to the table is increasing too much. You need to make it more efficient also for HANA to partition it in multiple portions based on the identity column. And finally, we harmonized our partitioning capabilities. You may know or not that hash range partitioning was following a non-heterogeneous partitioning schema. That was an older implementation of partitioning in HANA 2. You know, we introduced much more modern partitioning specification with HANA 2 SPS 6. We introduced that, and we called them heterogeneous partitioning schemas. And all new innovations are really relying on heterogeneous partitioning schemas, and we harmonized this also for the hash range partitioning so that you can also partition tables with the heterogeneous partitioning schema for hash range partitioning. And that's also in the context of NSE quite important because defining a load unit on partitioning level requires a heterogeneous partitioning schema. And with hash range now you can also support hash range partitions for heterogeneous partitioning schemas. I have to admit that hash range has been also supported for NSE with the non-heterogeneous partitioning schema. But anyway, I think that the key message here is hash range is now also supported as heterogeneous partitioning schema, and now all the range partitioning schemas that we have in HANA are harmonized in a heterogeneous partitioning schema. Also for the SQL syntax, it's quite important that you see all range partitioning schemas in your system have the same SQL syntax. It can be maintained much easier, and it's much more convenient. All right, I think, yeah, that's it from my end so far. I would like to thank you for your attention, and maybe you have the time. We have the time to have a look into one or two questions. I will stop my sharing. I think we had 3 questions that I see here. One question is, and I just repeated from the chat, once memory from buffer cache is released, if NSE usage increases again, memory is then automatically allocated with no significant impact to HANA, right? Exactly. This is, I think, also a bit the, how would I say, is what you need to do is to find the right way to define the unload threshold, that it's not too low, because then too much memory is released, and then the buffer cache is enforced to allocate once again, and maybe this happens then too often. But anyway, the allocation of memory has not too much impact, but if it happens too often because you release memory with the unload threshold, which is maybe too low, you need to reallocate again. And every memory allocation operation on operating system level has some or will eat up some CPU for sure. If it happens too much, too frequently, yes, it will have some small impact, I would say. But if it happens not too often, it has no impact. I haven't seen that from my end. So thanks, Fanny, for this question. And then another question came in from Nasher, 2012. The parameter reference index says the default is 50. I think, is it the default statement concurrency max limit? I said it's 0. I need to check. Thanks. I will need to check with the documentation. The final word has the documentation. So if you see the parameter then as default on 50, and I set on 0, I'm wrong. Sorry for that. But I will check with the documentation if it's right or not, and you will definitely see what is the right default value in the SPS 8 documentation. Okay, yeah, then I think no more questions that I see so far. Then I would like to thank everyone everywhere in the world, and thanks for following the session, and talk to you next time. Bye.
Bye. See you.
All right, the stream is
Good.
ended. Very nice.